everyone, myself Dr. P. Ashok Babu, working as Professor and Head, EC Department. In this video, I am going to discuss about the definitions of a second module, so which is magnetostatics. So the definitions are, first one is state Biot-Savart's law. So here the Biot-Savart's law states that the magnetic field intensity H produced at a point P by the differential current element ideal, where ideal is the current element, so is proportional to the product ideal and sine of the angle theta between the element and the line joining point P to the element, and it is inversely proportional to the square of the distance K between P and the element. So here, according to Biot-Savart's law, H is the differential magnetic field, dH is proportional to, so here it is the magnetic field intensity H is proportional at a point is proportional to the ideal and sine theta by K square. So it is the Biot-Savart's law. Next one is define Ampere's circuit law. Ampere's circuit law states that the line integral of the tangential component of H around a closed path is the same as the net current enclosed by the path. So here, according to the Ampere's circuit law, so here it is a line integral of H into dl is equal to I enclosed. So it is a Ampere's circuit law. Define magnetic flux density. So here the magnetic field is defined as the force per the magnetic flux density. The magnetic flux density is defined as the force per unit current element. The force per unit current element is known as the magnetic flux density. So what is the magnetic dipole moment? The magnetic dipole moment is the product of current and the area of the loop. Its direction is normal to the loop. So define magnetic vector potential. So it is defined as the quantity whose curl gives the magnetic flux density. So this is known as a magnetic vector potential. So what is the magnetization and its units? So the magnetization, M, capital M is known as the magnetization. Then M is the magnetic dipole moment per unit volume. Its units are amperes per meter. So what is the Lagrange force? Lagrange force is the force experienced by the test charge. So it is maximum if the direction of the movement of charge is perpendicular to the orientation of the field lines. Then state Lenz's law. So Lenz's law states that the induced EMF in a circuit produces a current which opposes the change in magnetic flux producing by the magnetic field. So this is known as the Lenz's law. Define transformer EMF. The EMF induced by the time varying current or EM wave. The EMF induced by the time varying current produced by the time varying magnetic field in a stationary loop is often referred as a transformer EMF in electromagnetic fields. So what is the time harmonic field? So a time harmonic field is the one that varies periodically or sinusoidally with time. Next, what is define the magnetic boundary conditions between the two media. So the normal components of flux density B is continuous across the boundary. The tangential component of field intensity H is continuous across the boundary. These two conditions are known as the magnetic boundary conditions. Next, what is the conduction current density? So it is the amount of current. It is the amount of current charges. It is the amount of current flowing on the surface of a conductor in a time t is known as the conduction current density. So this surface is always parallel to the current flow. What is displacement current density? It is defined as the time rate of change of electric flux density is a displacement current density. So what is main cause of eddy current? So here the main cause of eddy current is that it produces ohmic power loss and causes local heating. Next, define inductance. So it may be defined from the circuit that has the ratio of the magnetic flux linkage to the current. Define self-inductance. Self-inductance is defined as the rate of total magnetic flux linkage to the current through the coil. So what is a solenoid? So here a solenoid is an inductor coil consisting of multiple turns of wire wound in a helical geometry around a cylindrical core is called a solenoid. So distinguish between solenoid and toroid. So here a solenoid is a cylindrically shaped coil consisting of large number of closely spaced turns of insulated wire wound usually on a non-magnetic frame. So if a longer solenoid, if a long slender solenoid is bent into the form of a ring and thereby closed on itself, it becomes a toroid. I repeat the definition. So here a solenoid is cylindrically shaped coil consisting of large number of closely spaced turns of insulated wire wound usually on a non-magnetic frame, just like a circle. It is just like this. So if a long slender solenoid is bent into the form of a ring and thereby closed on itself, it becomes a toroid. This is the difference between solenoid and toroid. So in toroid, we are bending the total solenoid in terms of a ring. So it is a difference between solenoid and toroid. So define magnetic flux line. So the magnetic flux line is the path to which the magnetic flux density is tangential at every point in a magnetic field. This is known as a magnetic flux line. So what is a magnetic dipole? So a bar magnet or a small filamentary current loop is usually referred as a magnetic dipole. So what is relative permittivity? Relative permeability. So relative permeability is mu r. Mu r is a relative permeability. So it is the ratio of the permeability of a given material to that of free space and is known as the relative permeability of the material. So it is a dimensionless quantity. It is a dimensionless quantity. Next, what are ferromagnetic materials? Ferromagnetism occurs in materials whose atoms have relatively large permanent magnetic moment. So they are called ferromagnetic materials because the best known member is iron, because we will use the iron in that material. So the materials are known as the ferromagnetic materials. Define Faraday's law. Faraday's law states that the EMF in any closed circuit is equal to the time rate of change of magnetic flux linkage by the circuit. So this is the Faraday's law. Or it is, let us assume EMF is proportional to minus, it is a d lambda by dt. Is a Faraday's law. So define motional EMF. So it is in a conducting, let us assume a conducting loop. In a conducting loop, it is moving with uniform velocity u. A conducting loop moving with uniform velocity u as consisting of large number of free electrons. And the EMF induced in the loop, such type of EMF is called motional EMF, or which is also known as a flux cutting EMF because it is due to the motional action. I repeat the definition. Define motional EMF. So let us assume a conducting loop. In a conducting loop moving with uniform velocity, let us assume the loop is moving with some uniform velocity u as consisting of a large number of free electrons. Then the EMF induced in the loop, such type of EMF is called the motional EMF. Define Ampere's force law. Ampere's force law states that the force of attraction or repulsion between two wires carrying currents is proportional to their lengths and the intensities of current passing through them is a Ampere's force law. So what is the significance of displacement current? So here the concept of displacement current was introduced to justify the production of magnetic field in empty space. Production of magnetic field in empty space. It signifies that a changing electric field induces a magnetic field. A changing electric field induces a magnetic field. In empty space, the conduction current is zero and the magnetic fields are entirely due to displacement current. Next one, define magnetic force. So magnetic force or a magnetic force, which is also known as attraction or repulsion. The magnetic force of attraction or the magnetic force of repulsion that arises between electrically charged particles because of their motion. Next one, define magnetic field. A magnetic field is a vector field that describes the magnetic influence of electric charges in relative motion and magnetized materials. Next, what are the units of magnetic field strength? H. So in the international system of units, H is a magnetic field intensity. The magnetic field strength or magnetic field intensity is measured as ampere per meter. Is measured as a ampere per meter. Define permeability. So permeability is a mu is known as a permeability. Mu is known as a permeability. So a quantity measuring the influence of a substance on magnetic flux in the region it occupies is known as the permeability. I repeat the definition. A quantity measuring the influence of a substance on the magnetic flux in the region it occupies is known as the permeability of that particular field. To define inverse square law. So the inverse square law in physics is any physical law stating that a specified physical quantity or intensity is inversely proportional to the square of the distance from the source of that physical quantity, which is known as a inverse square law. Define Ampere's force law. In magnetostatics, the force of attraction or the force of repulsion between two current carrying wires is often called as Ampere's force law. Next, define magnetic moment. So the magnetic moment is the magnetic strength and orientation of a magnet or other object that produces a magnetic field is known as a magnetic moment. So what is the effect of magnetic field? So the effects of magnetic fields are commonly seen in permanent magnets. So which pull on magnetic materials and attract or repel other magnetic materials. So which is known as the effect of magnetic field. So what are the units for the magnetic flux density B? So the magnetic flux density B, the units for the magnetic flux density B are Weber per meter square. Weber per meter square are, so here the other one is Newton per meter per ampere. So there are two units for the magnetic flux density. The one is Newton per meter per ampere or Weber per meter square. So these are also units of the magnetic flux density. So what is a magnetic monopole? A magnetic monopole is a hypothetical particle or a class of particles that has, as its name suggests, only one magnetic pole is there. So if it is dipole, we have two poles. So both North Pole and South Pole are there. Because it is a magnetic monopole, so here we have only one pole, either a North Pole or a South Pole can exist. So define Gauss law for magnetism. So the Gauss law states that the magnetic flux density B has divergence, the magnetic has divergence and it is equal to 0. So therefore del dot B is equal to, so here del dot B is equal to 0. Del dot B is equal to 0 is one of the Maxwell equation. So define magnetic quadrupole. So a quadrupole or a quadrupole, which is also known as a quadrupole, is one of a sequence of configurations of things like electric charge or current or gravitational mass that can exist in ideal form. But it is usually just a part of multipole extension of a more complex structure reflecting various orders of complexity, which is known as a magnetic quadrupole or quadrupole. So define the electric dipole moment. So here the electric dipole moment is a measure of a separation of a positive and negative electrical charges within a system. That is a measure of the system's overall polarity is known as a electric dipole moment. So define permeability. So here a quantity measuring the influence of a substance on the magnetic flux in the region it occupies is known as the magnetic permeability or permeability of a magnetic material, which denotes as mu. So there are some definitions in magnetostatics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.